The first law of thermodynamics for open system. So already you know that open system means in which both mass and the energy will cross the boundary of the system. You can see here, let us consider this as the system. This is the container, so which is fixed with the stirrer, and some heater is also provided to supply the heat to the system. You can see here water is flowing in inlet and hot water is flowing out. So after getting heat, that means energy, both mass and uh, mass is entering inside and mass is leaving outside. Some work is done on the system by the stirrer and some heat is also added. That means energy is entering the system and energy is leaving the system. You can see here. So the same sketch, this is represented here. You can see here M1 indicates mass flow in, where M2 indicates mass flow out, where Q in, that is heat, is added to the system with the help of heater here, and some stirrer, it is doing some stirrer work on in this container on the system. That means some work is done on the system here. So it is explained here very clearly. Can see here the same sketch we have represented here. Let the rate at which heat enters the system from the heater be Q in dot. Let the rate at which heat enters the system from the heater be Q in dot. Dot means rate of heat transfer here per unit time. The rate at which work enters the system from the stirrer be W dot in. So this is the work done by the work done on the system by the stirrer, and this is the heat heat is transferred to the system by the heater. Now let the rate at which mass enters and mass leaves the system be m1 dot and m2 dot respectively. That is mass flow rate entering the system. Over dot indicates per unit time. So mass flow rate. So rate of mass flow, that means it is indicated by m1 dot. M1 dot indicates mass entering the system. M2 dot indicates mass leaving the system. Now let the mass of the system at a time t be ms. Mass of the system at a time t be ms, and its rate of increase of mass within the system, it is indicated by dms divided by dt. So whenever mass is flowing inside the system and some mass is flowing outside the system, so if mass entering and mass leaving the system, they are not in the same rate, then definitely there will be a rate of increase of mass within the system with respect to time. That is, it is represented by dms divided by dt. Similarly, let the energy of the system be indicated by ES. ES indicates energy of the system, and its rate of increase of energy within the system, or the rate of energy accumulation within the system with respect to time, it is indicated by DES divided by DT. Now, let us write the mass balance equation for an open system here. Now, according to the law of conservation of mass to the open system, what it indicates, rate of increase of mass within the system, that will be equals to rate at which mass entering the system minus rate at which mass leaving the system. That is, mass entering the system minus mass leaving the system will be equal to rate of increase of mass within the system. So rate of increase of mass within the system, how we have represented it by dms divided by dt, that will be equals to m1 dot minus m2 dot, according to this equation, that is according to this principle law of conservation of mass. That is dms divided by dt is equals to m1 dot minus m2 dot. Suppose if m1 dot is greater than m2 dot, that means mass entering the system is greater than the mass leaving the system, then this rate of increase of mass within the system, it will be positive, denoting that mass accumulates within the system, because mass entering the system is greater than mass leaving the system, then definitely some mass will be increasing, or it is going to accumulate within the system. Suppose if mass entering the system is less than mass leaving the system, then definitely this rate of increase of mass within the system will be negative, because denoting that mass is decreasing within the system, because outflow is more than the inflow, then definitely there will be a decrease in the mass. Suppose if m1 is equals to m2 dot, then dms will divided by dt will be equal to 0, because mass of the system remains constant with respect to time. Then there will be a no change, no increase in mass with respect to time. Then definitely this dms divided by dt will be equal to 0 only when mass entering the system will be equal to mass leaving the system is constant. Then definitely dms divided by dt will be equal to 0. Now let us write the energy balance for an open system here. Now, according to the law of conservation of energy, so how we are going to write this equation? Rate of increase in energy within the system equals to rate at which heat enters the system plus rate at which work enters the system plus rate at which energy enters the system with mass flowing in minus rate at which energy leaves the system with mass flowing out. So this is the law of conservation of energy. So rate of increase in energy within the system, how will represent it? DES divided by dt, because this indicates the total energy. E indicates total energy. So rate of increase in energy within the system, it is represented by DES divided by dt equal to Q dot. It indicates rate at which heat enters the system minus rate at which work enters the system. Why it is minus means work is done on the system here. Heat transferred to the system, it will be positive. Here work is done on the system, then definitely work will be negative here. Q minus W dot plus energy, rate at which energy enters the system with mass flowing in. So whenever mass is entering system, it is carrying some energy along with it. Energy in dot minus energy in, energy out. It is indicated by this equation. Now d by dt es, that is E indicates nothing but total energy. Total energy means addition of internal energy plus kinetic energy plus potential energy equal to q dot remains as it is minus w dot plus E in dot minus E out dot. Now this term I will this and this I will write at one side. So q dot plus E in dot equals to, so this entire term I will shift to left hand side, that is w dot. So if I will take this side, it will be plus plus. If I will take this side also, this will be plus w dot plus E out dot plus d upon dt of u plus kinetic energy plus potential energy. Now you can see here d of dt, the same equation I have written in this form here. Now d of dt u plus kinetic, this already I have explained here, you can see here. Now q dot, this E in dot means this indicates total energy entering the system, means it is nothing but internal energy plus kinetic energy plus potential energy plus this is nothing but flow work. Flow work also we have to add here, because mass is entering the system. So q dot plus this E in dot I have replaced it by, it is entering along with mass. So it is represented by m1 dot into u1 plus 1 upon 2 m1 v1 square plus m1 dot g z1 plus m1 dot p1 v1. This indicates the flow work which is entering the system equals to w dot I have kept as it is plus energy out along with same here m2 dot u2 plus 1 upon 2 m2 dot v2 square plus m2 dot gz2 plus, again this is flow work which is flowing out of the system, m2 dot p2 into v2 plus this I have kept as it is equation. Now q dot plus m1 dot I will take common, because it is everywhere mass is entering. Mass is common here, so m1 dot I will take common, u1 plus p1 v1 plus v1 square divided by 2 plus g into z1 equal to w dot, plus here also m2 is common, mass flow rate out of the system, m2 dot is common, so here it is u2 plus p2 v2 plus v2 square divided by 2 plus g into z2 plus this equation I have written as it is. Now you can see here q dot plus m1 dot. So u1 plus p1 v1 is nothing but h1, small h1, specific enthalpy. This is replaced by enthalpy plus v1 square divided by 2 plus g into z1 equals to w dot plus m2 dot. So here also it is replaced by specific enthalpy only, h2 plus v2 square divided by 2 plus g into z2 plus this equation remains as it is. So d by dt, here I have written u plus kinetic energy is replaced by 1 upon 2 mv square, potential energy is replaced by m into g into z2. So this is the equation for the first law of thermodynamics as a function of time for open system it is.